So in the last Git tutorial, we basically built some, in quotes, code, hello world, and committed that to our local repository. And we also discussed that there were, everyone, as it's a distributed version control system, everyone on the team can have a copy of the version control system, which is great because if you go home or you're on a flight and you want to work against the code base, you can because you've got a copy of it with you. And like historically, it's always sucked going off and working on something and then coming back on Monday, say, and then trying to work through merge conflicts or that sort of chaos. It sucks. So distributed version control systems allows you to prepare your merges and work offline, which is great. So in the context of that conversation, then we've introduced committing to a local repository, but then there's also you typically work with a remote repository as well that everyone talks to. You know, if there's another one on the person on the team called James, you're both committing to the same shared remote. So in our working copy, minimize him, don't care about him. So git status. So one thing I like is to have a tree view and of your commits. And it doesn't really make sense in the world of when we've got one commit, but it's also helpful for seeing what our status is with regards to the remote system. Because right now we can just see our local commits. So I have a command here, which is, let's bring that down, git config global, so make it a global configuration. Its alias will be called tree, and this is the command to run. So if I borrow this, copy and paste them in, I do the git config global alias tree. I think that's a copy and paste mistake. You don't need this piece here. So that now that's loaded into Git, we can say git tree, and it gives us a tree, albeit just a single leaf. But we've now got an extra bit of information here. You can see head is there, and I'll talk about what that is in a minute. But in this world, we don't see a remote machine. We still only see our machine. So let's go and add a remote system. So I'm running just off my local machine, which means I'm not connected to GitHub, I'm not connected to Bitbucket. And so we need to set up a remote on my own PC as well. So let's open up another terminal. Let's paste this in a YouTube origin for. So I've got a remote repository. And let's hook this one up to the remote. And I'm looking for upstream origin. There we go. Got the bloody thing added. So git tree. Let's look back at the command we added a while back. So it still doesn't see our remote instance. So let's try pushing to it. Okay, there we go. So in our list of things to talk about, so we've talked about local and remote, we've talked about tree, And then so the command we ran there was git push. Git push origin master. So that really is a push, which is basically synchronizes your content from your local repository to the remote repository. We're saying origin, lowercase origin, is the remote name. Because you could have a bunch of remote systems you're pushing to. And origin is the typical naming convention for your upstream. And then master is our master branch. So let's talk about that quickly. If you think about a tree, you've got the various branches coming off. That's a bad diagram. But trees have branches which have leaves coming off them. But the default branch in Git is called master. Then you can create your own feature branches that come off master. Maybe call it new feature. And you work on your new features and your bug fixes on separate branches, and when you're happy with them, you can merge them back into your master. And there's a whole bunch of branching strategies and workflow strategies that we'll perhaps talk about later. But for now, we're going to be working just for this episode, on master. So that's what's happening when we do git push origin master. And it may be the case that our current repository is set up so that we can hide this now that we've got this set up. Maybe the case that we can it knows where its default upstream instance is, that it knows that origin is our upstream. So let's just try. That's interesting. It says the current branch master has no upstream branch. So let's set this as well. Git push set upstream origin master. So there we go. Git branch master. Okay, so VV, I just said a git branch minus VV. VV is very verbose. And I'm just saying, hey, Git, for the current branch, what is the current status? Tell me about what you know. And he's saying his remote pointer, where he defaults to, is origin master, which is great. We want origin, that's our remote server in quotes. And master is the branch. And then so just doing a git push now is effectively flattened origin master, because he just knows to go to origin master there. So hopefully that made sense. There was a bit of tomfoolery just getting the instance set up and hooked up to the origin, but we're there now. So whenever we're working, let's talk about a few verbs that get quite confusing, I found, when I first started touching Git. There's a few words that you see when you're looking at resources and tutorials. There's pull, push, fetch, commit. So pull, or P-U-L-L, excuse my accent. But in my mind, these all sound sort of like they're working around the same sort of areas. Like commit, like fetch and pull sound like the same thing. Push and commit sound like they're the same sort of thing. But given time, you start to differentiate in your head the differences. So if we have our local repository and then the remote repository, aka origin, if we show some prettiness on this, if we do, you're always going to want to synchronize the two things. So if you've got a new someone's added a new file, b.txt, and your local doesn't have it, you would want to bring that downstream, right? So you have a b.txt locally. And so a pull, I'm going to talk at a high level here, I'll drill down to more specifics, but a pull will bring that down. And a fetch will tell you, so a pull will bring content down. I'm lying a bit here, just to simplify it, and I'll go into detail later. But pull will bring, just for our baby steps, pull will bring content down, and fetch will tell us that b.txt exists. So if we hadn't done, if we first just looked at the remote repository, we would see there's nothing there. If we did a fetch, it basically says, hey remote repository, has anything changed? And it would say, yes, there is a new file called b.txt, and it wouldn't bring it down. And pull does both a fetch, so it will tell us there's a b.txt, and he would bring him down. And then, so that is bringing things downstream, and then pushing things upstream. We have a push and a commit. Well, I wouldn't say commit is actually related to upstream. So a push would push your b.txt all the way over to, if you've made changes to b.txt, or let's say we've had a new file c.txt, it will push c.txt upstream. And a commit is to do with when we're working in our, do you remember we had the 3 different environments? We had our working directory, we had our staging area, and we had a repository. So this is just your local file system. You add changes to staging area, so it's now here, and then you commit them and they go into the repository. So that's the nomenclature split up for the really confusing synonymous verbs. So upstream push pushes content to a remote, and commit moves something into local repository. Power. So moving forward, where were we? So using our new git tree command, we can see that we are in sync with, we now have 3 tags on here, or 3 labels, sorry. We have master, which is our local repository master, and we have an origin master, which is our remote systems master. And we have head. So there's a lot of talking around these simple steps, But we'll move on to doing some fast changes, and you can slow the video down and see what's going on. But you need to know all this as to what's going on. So our machine, the remote machine, which incidentally is just another folder on my PC, just acting as a remote, in head. So let's borrow this SHA number. Let's say we had a bunch of commits. I'm going to just type in some numbers. So this was the first commit, second commit, third commit, fourth commit, and these labels that we see on here, they're just pointers to this tree. And this is just a flat tree. Everything's sequentially in order. But the first main thing to look at here is head. So head is where your system is pointed to, your main pointer. And as in our case, we've only got one commit. So head is pointing to this. And then if we had added 4 commits, pretend, head would be there. And we can move this pointer to anywhere we want. So we can go and look at the system at any point in time. If we move that pointer down to there, we will see how the file system looked at that point in time. In this world, we can see the origin, master, and master. If we were working in a world where we had 4 commits, it'd be the case right now that our local system was pointing there, the remote, and the master tag. So head is your current local where it's pointing to, and then we've got this remote tag, and then master is pointing all to the same place. So that's probably making your head spin a wee bit. It will make sense the more you watch and the more we interact with the system. And in the next episode, we're going to introduce a second developer working on code, and we'll be working to and fro with them on the code base. I hope that helped. Please put any comments in the or questions in the comment section below. I'll be happy to help.